and 180 on the bottom. Now if I ask you a question, when do we use this or when do we use this? We have two conversion factors, or which one is greater, this or this?
The first one.
The first one, definitely.
The first one is greater than the second one.
Yeah.
Okay. Anybody? Kathy?
I say the first one.
The first one. Any other answer? Most of them are the same. Most of them are the same. This is exactly the same as this. The difference is the equation, the numbers that's written is different. 1 mole means the same as 180.2 grams. 180.2 grams is 1 mole. So it's like 8 divided by 8. You put 8 on the top, you put 8 on the bottom. You put 8 on the bottom, 8 on the top. It's the same. It's the same. But the difference is, when do we use the first one, the first conversion factor? When do we use the second one, second conversion factor?
The first one we're converting to grams?
Yes, the first one, when you want to use to convert moles to grams. If gram is your final destination, if gram is the ones that you're looking for, so you put 180. Okay? The second one, when do we use the second one?
Converting to moles?
Yes, if you want to convert grams to moles. Moles is your destination. That time you're going to use a mole. Okay? We have a practical example here. For example, we have 100 grams of aspirin. We have 100 grams of aspirin, and we want to change 100 grams of aspirin into moles of aspirin. So we use this conversion factor because mole is on the top. Mole is on the top. So 100 grams of aspirin times 1 mole over 180.2, it gives you 0.55 moles. So this time, what we can say that we use mole over gram. Mole over gram, that gives you the amount of mole. Okay? Mole calculations in chemical equations will be the next slide. What is the purpose of, why we need to balance a chemical equation? First of all, let me ask you that way. What is the purpose of balancing a chemical equation? Why do we need to balance?
You start with that and you have to end with that.
Why? What's needed?
Because nothing disappears, nothing just,
Destroyed? Who said that?
you do.
No.
Law of condensation. Law of condensation of energy.
Well, not energy conservation of mass. The law of conservation of mass, this law was postulated by Dalton. It's a Dalton atomic theory, okay? And you know, every experiment is a proof of that. Whatever amount you start with X amount, and at the end you get the same amount. So how do you prove that? You need to prove by using a balanced chemical equation. A balanced chemical equation is not for beautiness. It's not for like we like it. A balanced chemical equation has its own practical purpose. Okay? You have to show. So to balance the chemical equation, you need to use what? Numbers in front of the chemical formula, which is coefficients. These coefficients are used to balance the chemical equation. Okay? Sometimes you have 1 and 2. So how many nitrogen you have on this side? 2. How many oxygen you have on this side?
2.
It's also 2. How many nitrogen you have on this side?
2.
2. How many oxygen you have on this side?
2.
So it means that the equation is what?
Balance.
It's balanced. The equation is balanced. Okay? The equation is balanced. So we need to balance the chemical equation to indicate that the total amount of the reactant here equals to the total amount of the product. Okay? So the balanced equation is also helping us to calculate more ratio. They used to calculate a similar ratio. So we use them as a conversion factor. Okay, we use them as a conversion factor. Coefficients are used to form mole ratios, which can be served as a conversion factor. Okay, So this is helpful to convert mole of nitrogen to moles of nitrogen monoxide, or mole of oxygen to mole of nitrogen monoxide by using mole ratio as a conversion factor. By using mole ratio as a conversion factor. Okay? Well, let's see some equation here. Using the balanced chemical equation, the balanced chemical equation is written here, right? The question is, how many moles of carbon monoxide are produced from 3.5 moles of C2H6? Okay. First of all, what type of reaction is this? When you study about this type of reaction, what did we say about this type of reaction? What do you call this reaction? A reaction like this, if oxygen is involved as one of the reactants, this is, what kind of compound is this? It is organic compound, right? And the name of this compound is called, do you remember? Ethane. Now, when organic compounds react,
doesn't it have oxygen?
Ethane doesn't have. You mean ethanol may have oxygen. Ethanol. Okay, ethanol is a derivative form of ethane. Okay, so ethane reacts with oxygen. It gives you carbon dioxide and water. Okay, it gives you carbon. That's a combustion. We call this combustion reaction. Glucose reacts with oxygen, gives you what? Carbon dioxide and water. Okay? This is called a combustion reaction. So mostly organic compounds, when they react with oxygen, they give you carbon dioxide and water. Okay? Now, whatever reactions that we deal with, there's one common feature, that all reactions have to be what? They have to be balanced. Yes, they have to be balanced. You can't, if you don't balance the equation, you can't answer all the questions. Sometimes the equation is balanced to you, just like here, but don't expect that the equation is balanced every time. It may be, or it may not be. Okay? Now, the purpose of balancing equation is not just to tell you that to respect the law of conservation of mass. The purpose of balancing equation is also an indication how much of the products that we get from the reactants. I can interpret this, or I can make a translation here, that every 2 moles of ethane reacts with 5 moles of oxygen, produces 4 moles of carbon monoxide plus 6 moles of water. The ratio is like that. If I have 2 moles of ethane, how many moles of carbon dioxide I get? 4. So the ratio between ethane and carbon monoxide is what?
2 to 4.
2 to 4. You see, that's the purpose. It's the purpose. That's the purpose of balancing the chemical equation. So, well, if 2 moles of ethane produces 4 moles of carbon monoxide, right? Well, if I have 3.5 moles of ethane, produces how many moles of carbon monoxide? That's how you need to ask. Okay? So
So
you
you
have,
add the 1.5 to the C, the ethane?
I'm sorry?
Would you add the 1.5 to that side?
No.
And balance it then, or like, how would you calculate that?
The way you calculate this, where do you want me to write? Here or here? Okay. Are you okay with that? You okay? Okay.
Yeah.
I have 2 moles of C2H6. Gives me how many moles of carbon monoxide? 4 moles of carbon monoxide, according to this equation. Okay. So let me turn on the light. Maybe it might be clear a little bit.
That's already turned on.
What?
You can see when you turn it off.
You
You can
can.
see better without light. Without looking for the people.
Oh, no. When I write this, just for writing it, then I can turn it off, okay? After that, I'll turn this off. So, 2 moles of C2H6 provides you 4 moles of carbon monoxide. If I have 3.5 moles of C2H6 provides me how many moles of carbon monoxide?
Oh, that's the cross, okay.
Yes.
All right.
We use crisscross. That means X will be what? 3.5 multiplied by 4 over 2. Okay? So what do you get? Give me the 3.5 times 4 multiplied by divided by 2.
7? Is that 7?
7? Okay, 7?
Yes.
Okay. 7?
Yeah, 7.
7. 7 what? 7 moles of what?
No, 7 moles of CO.
7 moles of CO. Do you understand? 7 moles of CO. That is 7 moles of carbon monoxide. So that equation is not possible if you don't have a balanced chemical equation. You can't answer how many moles of carbon monoxide can be generated from C2H6. I mean from 3.5 moles of C2H6. So the basic thing is you need to start with balancing the chemical equation first. Then we go from there. Okay, we go from there. Any question you have? Question regarding with this? Also water, yes. We can. Okay, now let me expand this a little bit by saying, okay, now for example, if I have, let me change this number a little bit. Instead of 3.5, I'm going to give you my number, okay? I would say I have 8 moles of C2H6. Okay, use this equation as is, and instead of 3.5, I want you to use 8. If I have 8 moles of C2H6, how many moles of water can be generated? How do you answer this question? What is the starting point? What is the approach? What you need to say is, oh, I'm sorry, 2 moles of ethane provides me how many moles of water? 6 moles of water. Where do I get this information? This information is from the balanced equation, right? Okay, if that is the case, let's say if I have 8 moles of C2H6, then how many moles of water should I get?
X.
X. So what do I do?
6 times 8.
I'm sorry? Crisscross, which is 8 times 6 divided by 2, which gives you what? I'm sorry?
24.
24
Moles of H2O.
moles of H2O. Okay? So, in order to answer this question, always you have to start with the balanced equation here. The balanced chemical equation tells you the ratio of the reactant versus with the product. How much reactant you have and how much product you get. See how much reactant you have and how much product you get. If you have 2 moles of C2H6, you will have 6 moles of water. If you have 8 moles of C2H6, you will have 24 moles of water. Okay, so it is very crucial that we need to balance the chemical equation. We need to balance the chemical equation. Okay? Can you write?
Yep.
Okay. Let me move the next one here. Let's do this one here. Ethanol comes from ethane. Ethanol comes from ethane, which is ethanol can be prepared by synthesized the reacting of ethylene, which is C2H4. Ethylene is the family of the alkene family, and it has a molar mass of 28.1 grams of mole, which means 28.1 grams comes from here, 2 times 12 plus 4 times 1, that gives you 28 grams, okay? So the way they prepare ethanol, the ethylene, which is C2H4, has to be reacted with water. It's called synthesis of water, synthesized with water, and then it's addition reaction. It gives you ethanol. Okay, I'm not going to ask you this on the test. Okay, I'll write down the reaction for you. The reaction will be written for you. That's going to be C2H4 plus water gives you C2H5OH. C2H5OH, which is, what is C2H5OH? You already said that earlier. Right? Ethanol. Ethanol, it's an alcohol. Like whenever you see OL group, ethanol, propanol, hexanol, all the OL ending, the suffix, OL suffix is an alcohol group. Okay? So in organic compound, OH refers to an alcohol group. In inorganic compound, OH refers to what? Basics, the basic groups, the alkaline products. Okay? If you have the H in inorganic compound, it refers to you what? The acids, hydrochloric acid, hydrochromic acid. Come on in. Okay. Acids, that's called the acids, okay? Good morning. Now the point is, how many grams of ethanol are formed from 14 grams of ethylene? Before I'm trying to solve this problem on a board, what do you think? How do we solve this problem? Let's say now we have a test right now. We are sitting on a test, okay? And we wanted to try to solve this problem. Tell me, what is your approach?
First, make sure that it's balanced.
Very good. First, Kiana said that we have to make sure that the equation has to be balanced. That's the key. That's the key. The equation, regardless of what, has to be balanced. Balanced means how many reactants you have, how many atoms or molecules you have on the reactant side, how many atoms you have on the product side. That's not balancing the equation. Okay, that's balancing the equation. Okay, so is the equation is balanced?
Yes.
Yes. Okay. How many of you say the equation is balanced? Raise your hand. How many of you say this equation is balanced? Okay, 1%. How many say 2%? How many of you say no, this equation is not balanced? How many of you say I don't know?
It's balanced.
Okay.
It's balanced.
It's balanced. Okay, 3 people say the equation is balanced. Okay. Balanced means that you just count the number of atoms on the reactant side. Okay? How many atoms you have on the reactant side and how many atoms you have on the product side? How many atoms of hydrogen you have?
4.
On the reactant side?
6.
6. On the reactant side, you have how many hydrogen atoms?
6.
You have 6. 4 here in ethylene plus 2. How many oxygen you have?
1.
On the reactant side. Let's go back with the product side. How many oxygen you have?
1.
How many hydrogen you have?
6.
How many carbon you have?
2.
How many carbon you have?
2.
So the equation is balanced. Right? This equation is balanced. Okay, so we don't need to balance the equation. Make sense? The only difference that this equation is written in the form of what? Molecular formula, empirical formula, or structural formula? Structural formula. It's written in structure, like you see the bond, you see the atoms, how they are connected. And the structural formula tells you more, it provides you more information, in fact, than the molecular formula because it tells you what is the central atom and how the atoms are connected. Or if you want to interested about the angle between the carbon and hydrogen atoms, there is a lot of information here. Okay? So, but you know, whether it is structural or whether it is molecular, what is the point? The point is the equation has to be balanced. They have to be balanced. They have to have equal number of atoms and molecules on the reactant side and equal number of atoms of molecules on the product side as well. So, okay, we did the first part. The first part, the equation has to be balanced. Okay, what's the second part?
It's that form.
I'm sorry?
Rewrite it to like the equation form.
Okay, we don't have to. You don't have to.
For the ratio between both of them.
What ratio?
Between the reactant and the product.
Okay. Now, when you say ratio, wait. When you say ratio, there is a mole to mole ratio. There is a mass to mass ratio. Which ratio are you interested here?
Mass.
Yes. Yes. We are interested here a mass to mass ratio. Why?
Because it says how many grams of ethanol are formed.
Yes. Because the amount is given in mass. Okay? So I don't need to go all over to convert the mass into moles. I can compare a mass ratio to the mass ratio of water, a mass ratio of water to the mass ratio of ethanol, the molar mass ratio. So according to here, how many grams of ethanol are formed from 14 grams of ethylene? That was the question. What's that? How many grams of ethanol, which is this ethanol, are formed from 14 grams of ethylene? So how do you set up the problem? How do we set up the problem? Okay. Maybe I can.
Professor, the 46.1, isn't it the grams of ethanol?
Where is 46.1?
46. I mean, that could be ethylene. That could be
Ethanol, is it ethanol?
Ethanol,
Oh,
yeah,
ethylene.
ethanol, yeah. 46.1, that's ethanol, that's right here.
Right, okay.
Isn't
And
it
that's
46.1?
28.1.
What's that? The question is, what is the molar mass of ethylene? 28.
28.1.
What, 28.1, okay. 28 28.1 grams of ethylene, which is C2H4, okay, provides me how many grams of ethanol? 46.1 grams of ethanol, C2H5OH.
So it'd be 14 grams.
14 grams of ethylene, C2H4, provides me how many
X.
moles of ethanol? This ratio is said to be a mass-to-mass ratio. A mass-to-mass ratio. So this is a mass-to-mass ratio. So X will be what? 14 grams times what? 46.1. Okay, this close.
Divided by 28.
Divided by 28.1.
Isn't gram per mole different from grams?
Gram per mole is the best way to express it. I mean, I would say gram per mole. That means gram per mole, numerically they are the same. But more ideal or more practical is write gram per mole. Like for example,
Because what they gave us in the example is gram per mole, and the 14 is just in grams.
yes, that's true.
So, I'm thinking it's gram per
Of
mole
course.
different from grams.
Because this means this is 1 mole of ethanol is 46.1 grams. This means 1 mole of ethylene is 28.1 grams. But we don't know the amount here, it's just 14 grams. This is a value per mole. Yes. You're welcome. So what's X here?
22.96.
22.96 grams of what? Ethanol. Okay, if you have any questions, please ask, okay? If you have any questions, please ask.
This is something what she's saying, I have a hard time, because like the way you said it, 28.1 grams.
Per mole?
Yeah. I was, but I was thinking the more wouldn't be there.
Here, okay, let me explain this. For example, what is 1 mole of water equals to? 18 grams.
Yep.
1 mole of water is 18 grams. So I say mole of water, 1 mole of water is 80 grams per mole. That's the best way to write it, because 1 mole equals to 18 grams. But let me tell you this, if I have 28 grams of water, how many moles it is? You see, notice here that I didn't say 28 grams per mole. I didn't say that, because it's not 1 mole. If it is 1 mole, it's a gram per mole. But if I have X amount of grams, but it's not mole, because I'm not sure whether it's 1 mole or not. It's the same way here. You have 28.1 because that's 1 mole of ethylene. But 14 grams, maybe less than 1 mole, maybe more than 1 mole. So we're not exactly sure. So we don't use per mole, we just write the amount. Okay, Sandy, does that make sense?
Yeah.
Okay. Any question? Question? Okay, so let's move to the next one. Okay. You know, sometimes the book goes like in longer ways, but the best way is to understand the concept. Okay. We have. Anybody has a textbook? Maybe I can add one more example because I don't think this is either. Can I borrow the textbook? Thank you. Maybe I can give you some example from the textbook and see if this is.
Right,
Yes.
right on here, you have C2, H5, O4H, non-is different.
What's different?
For ethanol, H6O.
It's the same thing. C2H6O or C2H5OH counts the number of hydrogen atoms and counts the number of oxygen atoms you have.
So it's the same thing?
It's the same thing. Yes. Okay, let's do this as a classwork. Maybe it's a problem that is from the textbook. Okay, 147. Okay, I'm going to read this for you. I want you to write this. Okay, those of you who have a textbook with you, I'm on page 147. Page 147. Problem 5.24. Okay, what it says is use the balanced equation. N2 plus O2. What's N2? Nitrogen plus oxygen gives you nitrogen monoxide. What is the chemical formula for nitrogen monoxide? I'm sorry? NO, yeah. it gives you NO, which is nitrogen monoxide. Everybody got that? Nitrogen plus oxygen gives you NO. Is the equation is balanced?
N2,
42, or approximate that value.
I got 20.
20. You got 20.
Yes.
Okay, 20, 21, it's close. How about the other guys there? What you got there? For the first one? No? What numbers you got?
We do not have a clue.
Okay. Okay, all right. You didn't try that. Okay, well, we got to. Okay. Okay, let's do this together. I thought. Okay. Okay, please look. Okay. The questions that we have was nitrogen reacts to oxygen gives you 2NO. We agree with this, right?
Right.
yeah.
Please look carefully because after break you may have a taste. No, of course, yes, because you should have a taste. So we have to be honest to tell you now. So let's first understand the concept. Okay? Is this equation is balanced? Always that you need to ask yourself. Is the equation is balanced or not?
Yes.
How many of you say yes? Okay. How many of you say no, I don't know? Don't worry. You know that's right. Okay. The equation is balanced, right? So the first question that was given to you was, can you read?
How many grams of NO are formed from 10 grams?
How many
Grams of NO,
grams of
NO
NO
formed
formed
10
from
grams of nitrogen.
10 grams of
nitrogen.
nitrogen? Let's do this one first. How many grams of NO is formed from 10 grams of nitrogen,
So
right?
N2 equals 2NO, right?
Yes, according to the mole ratio, 1 mole of N2 equals to 2 NO, 2 moles of NO, yes. According to this, right? But we're not dealing with mole. We are directly goes to mass. Here is what I'm going to do. What is 1 mole of N2 equals to in terms of grams?
28 grams.
I'm sorry?
28 grams of, yeah, 28 grams.
1 mole of N2 is 28.
Okay.
Let's agree with this right now. One mole of N2, nitrogen. This is N is nitrogen, right? The molar mass of nitrogen is 14.
And it says
So
28.
times 2 is 28.
Right.
Does that make sense, Kathy? Because nitrogen, the atomic weight of nitrogen is 14, 14 times 2 is 28. So 28 grams of nitrogen provides you
60 grams of NO.
60, 60. 60 grams of NO. Yes or no? How did you get 60?
Yeah.
14 times
14 is for nitrogen, 16 is for oxygen. If you add this up, it gives you 30, 30
yeah.
30 times 2
16.
is 60.
I'm not understanding.
Say
Okay.
that one more time, real quick.
Okay. 1 mole of NO means that N is 14 grams,
Right.
oxygen is 16 grams. That gives me 30 grams. But I have 2 moles of NO. So this has to be multiplied by 2. That's how I came up with 60. That's why I came up with 60. Are we agree with that? So 28 grams of nitrogen provides me 60 grams of NO. Then if I have 10 grams of nitrogen, provides me how many grams of NO or nitrogen monoxide?
21.
I use crisscross again, right? So X will be 10 times 60 divided by 28.
600 over 28.
600 divided by 28, yeah.
It
And it gives me
21.42 grams.
okay, 21.4 grams. Oh, I'm sorry, of NO. Make sense?
We can also,
Yeah, go ahead.
we can also do that, like 60 grams of NO divided by 28 grams of N2 times 10.
60 grams of NO divided by?
28 grams of
Yeah,
N2
yes,
times
yes,
10.
yes,
Yes.
yes, you can do that.
Completely.
You can do that. It's you know, there are different ways to solve it. Yes, you got the same answer anyway. Any question? Yeah.
Yes. Do we always have to multiply by the coefficient? The two?
I would. Yes.
We always have to.
Yes.
multiply
If
by-
you have coefficient, you have to multiply by the coefficient.
So if there was 2 in front of oxygen,
Over here?
I'll multiply 32 by 2.
By 2. Yes, it's going to be 64.
Alright, thank you.
Mhm. Yes. Any other question?
And nitrogen is 14 grams. Where did this number come?
Because nitrogen is a diatomic molecule. There is 2 here. So one nitrogen is 14 grams. Yes. But you have N2, not N. That means you have a nitrogen atom bonded to another nitrogen atom. It forms N2. It's a molecule. Yeah, it's from the periodic table. The periodic table here, nitrogen is 14 grams. Nitrogen is 14. But we have, if it is one single atom of nitrogen, it is 14. But the problem that I gave you was not N, but it is N2. That means it's going to be 2 times N, 2 times 14, 2 times 14, that's 28. Yes, yes. Okay. Now the second question, the second problem. How many of you solved the second problem? I'm going to do the second problem here. One here, one there. Okay. How many of you did the second one? What you get? What's your answer?
18.75 grams of nitrogen monoxide.
Okay. Again, we're going to use the same equation. Okay. The equation we have is N2 reacts with oxygen gives you what? 2NO. 2NO, nitrogen monoxide. Now, what was the question? The question says, how many?
10 grams of oxygen will give you how many grams of?
How many grams of NO
From 10 grams of 10 grams.
from
10 grams of
10 grams of what?
oxygen.
Oxygen. How many grams of NO we get from 10 grams of oxygen? Right? So how do we solve the problem? How do we solve this problem? Okay, just like what we did here. O2. What is O2? What is the molar mass?
32.
32. O2 is 32. Grams of oxygen provides you how many grams of nitrogen monoxide? 60 grams of NO. If you have 10 grams of O2, how many grams of nitrogen monoxide you need? It's going to be 10 times 60 divided by 32, yes. 600 divided by 32.
18.8 grams.
18.8 grams of NO. Question? You have any question? You can ask question now. Grams, yes.
Wow.
18.8 grams of NO.
I know, I see how you got the oxygen, you get 16, but I'm still confused on how you got 60.
60 comes from the molar mass of NO, which means NO has nitrogen and oxygen.
Okay.
N is 14 grams, oxygen has 16 grams. That is the atomic weight of oxygen is 16. That is 30. However, when you look at the balanced equation, you have 2 times of NO. So that means you have to multiply this by 2. That's how you came up with 60 grams of NO.
Okay, and so then you did.
And then I compare the amount of oxygen with the amount of nitrogen monoxide, which is 32 grams, compared with 60 grams. 32 grams because oxygen is 32. You have 2 oxygen, remember?
Yes.
So 32 grams with 60. And if I have 10 grams of oxygen, how many grams of NO would I get? So I make a comparison between oxygen and nitrogen monoxide.
Okay, so you did 10 times 60 divided by 32.
Yes, 10 times 60 divided by 32. So that's why I came up with 80.8. Right? Beverly.
I'm just looking at it. Yeah, I'm trying to figure it out, yeah.
Okay.
Yeah.
Any other question?
To the crisscross. You understand that? How you get the equation?
Yeah?
Yeah, I understand how you got the 60. I'm saying that.
Okay. Any other question we have? Okay, let's move. Oh, we have the third one. We have the third one. The third one. What does the third one say?
How many grams of oxygen is needed to react completely with 10 grams of nitrogen?
How many
Grams of oxygen.
grams of
Oxygen
oxygen is needed? Go ahead.
to react completely with 10 grams of nitrogen.
To react completely with what?
10 grams of nitrogen.
10 grams of nitrogen. Now you need to understand the problem first, okay? This time, you're not going to compare reactants to products. This time, you're going to compare what to what? Reactant to reactant. That is really very important to understand the question. The question is not how much nitrogen monoxide you get at the end. That's not the destination, that's not the goal. The question is, how many grams of oxygen is needed to react with 10 grams of nitrogen? So you're going to compare nitrogen with oxygen. How do you answer this? What's your approach?
28 grams of nitrogen reacts with 32 grams of
Yes,
oxygen.
yes. What you need to say is 28, according to this, 28 grams of nitrogen needs how many grams of oxygen? 32 grams of oxygen, because it's 1 to 1. The ratio is 1 to 1. 1 mole of nitrogen is 28 grams. 1 mole of oxygen is 32 grams. So every 28 grams of nitrogen requires 32 grams of oxygen. Okay? Then, if I have 10 grams of nitrogen, how many grams of oxygen should I need?
320 divided by
So X would be, again, 10 times 32 divided by 28.
320
320 over
over 28.
28. That gives you what?
11.4 grams.
11.4
0.4 grams
grams of
oxygen.
oxygen. Okay? Does that make sense? Any question? Yeah? Okay, we're going to move to the next one. We're going to discuss about types of reaction. We have oxidation and reduction. Okay? What is oxidation means? Oxidation is the loss of electrons from an atom. The simple definitions of oxidation is, maybe you can say oxidation is combining with oxygen. Okay? But it's very limited. Just a combination. Something reacts with oxygen, sometimes it's called combustion reaction. So. But the best definition for oxidation is defined as the loss of electrons from an atom if a substance loses electrons and in the process of reaction, it is said to be oxidized. Oxidized. Reduction is the opposite. It's a gaining of electrons by an atom. So, you know, whenever there is a chemical reaction, there is oxidation and there is also reduction. It's a simultaneous process. This can happen at the same time. So, it is called redox reaction. Redox. Redox is an abbreviation for oxidation and reduction. It's like a summary. It's like a simultaneous. Whenever there is oxidation, there is also reduction. So, you can say it's redox. Redox means it is a transfer of electron from one element to another. If there is a transfer of electron, one atom loses electron, the other atom gains electron. So if you have oxidation, then what comes next? The reduction. If you have oxidation, there is always reduction. So the process is said to be a redox reaction. It's a simultaneous process. Okay? You can see oxidation and reduction here. Okay? Maybe we have done this in the lab sometimes, you know. A copper and zinc. A redox reaction occurs when a strip of zinc metal is placed in a solution of copper to ions. What's happening here when copper summits, it can be, for example, copper sulfate. Okay? It is like, maybe I can write this. Let's say you have a solution. You remember the copper solution have a blue color? Have you noticed that? Maybe when you do the experiment in the lab, copper has a blue color, right? Yeah. So it can be maybe one of the copper sulfate solution. Okay, it can be copper sulfate or copper chloride. Anyway, copper, when it dissolves in water, it provides a blue color, a light blue color, or you know, a dense blue color. But it gives you something nice blue color actually. That's how it generates. Now you put zinc metal here. That is zinc metal right here. Okay? So you dip the zinc metal in a copper solution. Okay? Then the reaction. There is oxidation and reduction reaction. There is a redox reaction. What's happening is that copper has a charge of +2 here, right? And copper is going to be replaced by zinc. It's going to be 0. Okay? So oxidation number of copper is going to be 0. So that means zinc has, if an element is by itself, just a single element by itself, its charge is 0. Because it doesn't lose or it doesn't gain, right? But if it reacts with something else, it has a charge of +2. Okay? Now, if it has a charge of +2, okay, let's look here. Copper +2 goes to copper 0, and zinc 0 goes to zinc +2. What is happening in the first process? You have copper +2. What does +2 tell you? It is a positively charged ion, right? That means there is a lack or a shortage of electrons here, right? But when it gets to 0, that means it gains electron. That's why it's balanced now. It gains electron. Okay? So gaining of electron is said to be what?
Right.
Yeah. Yes. Yes. Faith.
How is +2 to 0 gain of electron?
Here, it gains 2 electrons. I'm just trying to picture this out in the form of equation. We have, in a solution, it is copper +2. When you dip that solution, which is copper +2 solution, in a zinc metal here, then the zinc metal is more reactive than copper, then it removes the copper from the solution. It removes the copper from the solution, and then the copper is going to be free here. That means the copper is going to be free, means its charge is 0. Look here, there's no charge here. But the zinc got a charge here. What is happening? Redox reaction.
I understand that part.
Yes.
I don't understand how +2 to 0 is.
This is reactant phase. This is reactant here. This is product here. I'm just doing the same way. This is reactant here. This is product here. That is a picture of this.
Yeah, I understand.
Okay. On the reactant side, copper has a +2 charge because it was copper sulfate. Zinc has 0 because zinc was a single element. I had the same thing here, copper sulfate with a charge of +2 and zinc was 0. Then I dip the zinc metal in a copper sulfate solution. Zinc is reactive than copper. The zinc replaces the copper from copper sulfate solution.
In the SO form.
SO4, that is my thinking. It might be SO4, it might be chloride, because it's a compound, right? If it is a compound, it can be zinc chloride, it can be zinc sulfate, you name it. Zinc bromide, doesn't matter.
Is that when the copper dissolved and dissipated in the solution when it dissipated?
Yeah, the copper is extracted. The copper is, you see the copper? The copper, red color here, it's coming here. The copper is removed from the copper. The copper in a solution was a blue color. When the copper was removed, it gives you a reddish color, the original color. That means a pure copper. That means the charge of copper is 0. That's solid now. That's why you see S here.
Yeah, Professor, I'm very sorry, but I really need to get clarity.
Okay.
Because C2 becoming 0,
Yes.
that should be loss of 2 electrons.
Yes.
Not gain, but you said copper gained electron.
Yes.
You said
Yes.
copper gained 2.
Yes. Copper gains electron, yes.
So it already has.
-2?
No,
you gain electron
no. Look, okay, tell me the difference between sodium plus versus with sodium 0. Simple example.
Sodium plus,
Sodium plus 1 with sodium 0.
sodium plus 1 lost 1 electron.
Very good. Now, write that down. Sodium plus 1 lost 1 electron.
Oh my goodness, I don't understand.
I understand. Okay, very good. Very good. You see, sodium lost electron. That's why you have plus 1. Is everybody clear with
Yeah,
that?
but on that one it's +2.
Because it lost 2 electrons.
So it loses
It gets back the 2 electron and it becomes 0.
Oh.
They become balanced now. Deficiency of electron, richness in electron. Poorness in electron, richness in electron. High amount of proton, less electron here. This is electron and proton are the same here. That is what it is 0. It is neutral. It's not charged. Does that make sense?
Yes.
Because copper gains electron, is copper is oxidized or reduced? Yes, copper gains electron. Reduced. Copper takes a process of reduction. Yes. Because zinc lost electron, because zinc was 0 here, zinc become +2. What happened?
Oxidized.
Why is oxidized?
That's what it says.
No. It is oxidized because it lost 2 electrons.
Yeah.
It lost 2 electrons. Loss of electron is oxidation. Gain of electron is reduction. Okay? Loss of electron is oxidation and gain of electron is reduction. Let's always think about that. See as a future.
So the copper +2, they lost electrons, so it gained 2 more back to become 0.
0, yes. 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 That means copper is reduced.
Okay.
Copper has reduction.
So it was positive, or positive 2 until it went to the solution, and then it came
And
out.
it came out 0.
Okay.
Why it came out 0? Because it gains that 2 electron.
Okay.
And it become balanced. It become balanced. Okay. Here, what? This is the best explanation now. Okay? Over here, whatever I put over, this is the reactant side, this is the product side. This is a zinc metal, strict metal zinc. This is a copper solution. In a you dip this zinc in the copper solution here. Copper 2 gains 2 electrons, it becomes copper.
Because 2 cancels 2. Right?
Yes, zinc was lose 2 electrons, it becomes zinc plus 2. So zinc is oxidized. Zinc is oxidized. Copper is reduced because copper gains electron. Zinc loses 2 electrons from zinc plus 2, so zinc is oxidized. Copper 2 gains 2 electrons to form copper, so copper 2 is reduced. And the whole process is called redox reaction. Redox reaction. Redox means oxidation and reduction.
So the zinc will be disappeared.
No, zinc, yes, as a metal is disappeared, but it is in the solution. It is in the solution. And copper was here in a solution, copper was out of the solution. And you see the red color in the previous chart, that red color is a pure copper. And copper is burgundy red or red, something like that, right? So that's copper. Reduced means it's extracted, it's removed from the solution and it's by itself. That's what it means, okay? Okay. I'm sure that there is a let me maybe give you, okay, all this here maybe it's just a practice for you. All these are oxidation reactions. Look, this is oxidation, 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 oxidation. Now, what is the difference here? Sometimes it might be trick for you. This is oxidation because it lost an electron. How many electrons it lost? 1 electron. This is oxidation. It lost how many electrons? 2. Now, why this one lost 1? Why this one lost 2?
Because that one only had 1 to lose to become stable, and that one only had 2 to lose to become stable.
Because sodium is in group 1, and it has to lose 1 electron to become stable, or to form a compound. Because the valence electron of sodium is 1. The valence electron of sodium is 1. Magnesium is in group 2. It has to lose 2 electrons.
Okay, the fourth one is confused.
The fourth one is confusing. Okay, the third one, by the way, is also confusing. Because you may think about this, chlorine is in group 7, right?
Yeah.
Chlorine lost 2 electrons here. Chlorine is supposed to lose how many electrons? 1, right? But you have 2 times of chlorine. 2 times 1 is minus 2. Okay? Oxygen, one single oxygen has a minus 2 charge, but you have 2 oxygen. Times 2, it has to lose 4 electrons. 2, the coefficient times subscript. 2, the coefficient times subscript. Okay? No subscript, so that's why you have only 2 here. Whereas reduction means, you see, one thing that we can tell oxidation and reduction. Reduction is what? Gaining of electron. Think about this way. I don't know if it helps us. Think about endothermic and exothermic reaction. Endothermic is getting into to the reactant. Exothermic is out. So, oxidation, is it endothermic or exothermic? Exothermic. Reduction, is it endothermic or exothermic? Endothermic. Reduction, gaining of electron to the reactant side. Oxidation gives away electron. Think about oxidation gives, just like exothermic reaction gives away heat. So this is like oxidation. This is like oxidation. So you gain electron here, it gains to the reactant. So how many electrons it gains? 2 electrons. So it should be 2 minus. It's a reduction. It gains 2 electrons. It gains 4 electrons. It gains 2 electrons. It gains. If anything is on the reactant side, it gains. It's not loss. It's profit. I kept it because it's on the reactant side. Yes, I'm not losing. I'm not really I'm profitable here that these are lost. They are oxidized, but these are gained. This is like exothermic process, like this is like endothermic process. Yes, I would study that way, so that might be easier for you to understand oxidation and reduction. Okay. Okay, here for example, examples of oxidation reduction reactions, iron rusting. Rusting iron, process of rusting, is it a chemical change or a physical change? It's a chemical change, okay? So what will happen? Rusting, what is rusting? Rusting is oxidation process, right? Yeah, you can say that, but there is, the reality is all reactions are oxidation and reduction reactions. Whether it's a combustion reaction, whether it's a metathesis reaction, whether it's a single replacement reaction, there is always transfer of electron space. If there is transfer of electron, something has to be oxidized, something has to be reduced. There is oxidation and reduction. So in this case, you have your bike, nice bike. So you leave your bike in your backyard for a month's time. It was iron, right? It was pure iron. After a month, when you come back in your backyard, it is rusted. That means the neutral iron, that's good iron, somehow is oxidized. Oxidized, loose electron. Its electrons are removed, it is oxidized, it becomes like, it reacts with oxygen. Rusting is a process of oxygen with air, with moisture, with whatever you have in the outside.
So if you cover it up, are you going to save it?
If you cover up with aluminum, for example, with some elements that protect oxygen not to come, yes, you can keep it. Okay? So that's why you want to keep in the garage rather than living out, because you may not get enough amount of oxygen inside, in the house, in the warehouse, for example. But if you leave it outside, obviously, there is excess amount of oxygen from the atmosphere, and there is rusting. Right? There's rusting. So you get iron plus 3, but the chemistry, if you break up this chemistry, what is happening is that the iron lost electron. It becomes plus 3. That means iron is oxidized. Iron lost electron. Oxygen, on the other hand, whatever. And one important thing that you should know, if iron lost 3 electrons, oxygen has to gain also 3 electrons. It has to be balanced. The number of electrons lost by the metal, the number of electrons gained by the non-metal, they must be matched. Okay? 3 to 3, 6 to 6, whatever. In most cases, what do you think? General question. Do metal oxidized always and non-metals reduce always?
Yes.
In most senses, yes. In most cases, the answer would be yes, because metals always lose electron in chemical reaction, and non-metals gain electron. If you ask me why, it is because of why.
For it to be stable.
Yes, but why metals lose electron? Mostly, there is a reason behind that.
Ionization energy.
Excellent. Ionization energy. Ionization energy. Metals have high ionization energy. You can't, no, wait a minute.
No.
Metals have low ionization energy. Metals have low ionization energy. It is easy for metals to lose electron. Non-metals, on the other hand, has high ionization energy, so non-metals, they love electrons. They don't want to lose electrons. Okay, so if someone asks you, why do metals lose electrons? What's the reason behind it? Because of ionization energy. It is easy to remove what? To remove valence electrons from metals, because metals have low ionization energy. Okay. Okay, energy. energy. When molecules come together and react, bonds are broken in the reactant and new bonds are formed in the product. Okay. When you have a chemical reaction means that bonds are broken and new bonds are formed, right? If you want to break, always you have to have some energy. You have to invest some energy, okay? So breaking of bonds always needs input of energy. Bond formation, if bonds are formed, it releases energy. So if, for example here, to attach a chlorine atom with another chlorine atom, to cleave this bond, you must have about 58 kilocalorie per mole. 58 kilocalorie. A kilocalorie is a measurement for energy. Is needed. This is an experimentally determined value. Okay. If you want to, if a form is bonded, if this one is like, if you want to break up this, if you want to break up this, you must have this much energy. If you want to bring this bond together, formation of bonding is like exothermic process. So like 58 kilocalorie per mole of energy is released. The amount of energy which is used to break up bond, the amount of energy which is used when they form bond has to be the same. This is also related with the law of conservation of energy. The law of conservation of energy. Bond formation is exothermic process. Breaking of bond is endothermic process. You want to break a bond, you need to have energy anyway. Heat energy, electrical energy, some type of energy to break up the bond, right? How do you break up the water molecules? Let's say you want to break water molecules into hydrogen and oxygen. You must have some energy, right? It might be heat energy or it might be electrical energy to separate the molecules of water into hydrogen and what? Oxygen. Yeah, here it says, by the way, delta H is used. It is the energy absorbed or released in a reaction. Delta H is called the heat of reaction or enthalpy change. Enthalpy. Enthalpy is like a Greek word. Okay, enthalpy means heat. That's nothing. Enthalpy means heat. But we use pretty much H as heat versus with enthalpy because enthalpy is always related with pressure. Okay? If you say heat, you don't consider pressure. At what pressure? Let's say we want to measure the heat transferred from one substance to other substance in this room. So we know the pressure, the room temperature and the room pressure in this room. So if you consider pressure, if you have a measured pressure value, then we call this enthalpy. If you ignore pressure, that is heat of reaction. So most reactions are under pressure, right? You have a constant pressure. You have a room pressure, you have a laboratory pressure, there is some pressure there. So pressure is a factor, pressure is a significant part. So that's said to be enthalpy. That's the difference between enthalpy and reaction. So when energy is released, the reaction is said to be exothermic and delta H is negative. Negative value is also indications that energy is given out. Okay? It doesn't mean that it is less. It does. There is no like minus energy, but it tells you that the system loses energy. The system gives out energy. So if something is given out, you say it is negative. Okay? When delta H is negative, which is exothermic, meaning to say more energy is released in forming bonds than needed to break the bond. There is more energy that's released. The products are lower in energy than the reactants. Okay, that products are losing energy. These are the products. Say for example, we have CH4, methane, reacting with oxygen, and it provides you carbon dioxide, water, and heat. Natural gas, the gas that we're using in our daily life, the main component is methane. 90% of the natural gas is methane. So methane reacts with oxygen, gives you carbon dioxide and water, plus heat energy. Heat is released. So products are low energy because they are giving away energy here. Okay, they are giving away energy here. This is what type of process? This is exothermic process. Exothermic process. I can give you an example of exothermic. A good example that you use in daily life is hot pack and cold pack. Ice pack and hot pack, right? The idea of ice pack and hot pack is really endothermic and exothermic process. Someone is swallowing and you want to put a cold pack, what do? You first squeeze it. You first squeeze it and you put on the part that's swallowing, right? You put there. What do you feel? You feel cold. Tell me what's happening. That means the cold pack actually takes away the heat from your body. It absorbs energy. So that process is what? That process is endothermic. It takes. Whereas hot pack, again you squeeze it, you feel very cold. When you put it in your body, you feel what? Warmer. You feel warmer. That means that hot pack generates heat. The system, which is hot pack, is actually the chemicals that is inside there are calcium chloride and water. Why you squeeze it? Because you want to break the membrane that has, on one side you have pure water, on the other side you have calcium chloride. So when you squeeze it, you break the membrane, you break that wall, so that the water and the calcium chloride, they react. They react, chemical reaction. When they generate chemical reaction, the chemical reaction generates heat, which is exothermic. Minus H, delta H is going to be some value. We're going to calculate that. How much energy is needed? We can calculate that.
Yeah, so Professor, is there a two-way reaction? Can we say it's a redox reaction because it's taking away the heat from the body and the body gaining the coldness?
You can say that. Yeah, you can say that. But the point here is what I would like to show you, that endothermic is always absorbing heat from the surrounding. You are the surrounding. Okay? The system is the calcium chloride and the water. No, for example, for the cold pack is not calcium chloride. The cold pack is ammonium nitrate, NH4NO3. The cold pack absorbs heat from my body. It absorbs heat. So where does that heat go? That heat goes to ammonium nitrate and water. So the ammonium nitrate and water gets more energy, so it is endothermic process. Okay? Endothermic process. Exothermic means sometimes when you do chemistry in the laboratory, just check around, just touch the test tube. When you mix chemicals, maybe we may do this next week, I don't know, I mean after spring break is open. Just touch the test tube, touch the beaker, and see for yourself. Every reaction can be either exothermic or endothermic. If you feel warm, then, it doesn't feel that much warm, but if you feel warm, it's exothermic process. It releases energy. Your goal is how much energy is measured. You can calculate that, of course. This can in fact, we did this yesterday. We did this yesterday, right? In the lab. What's that we did? Obviously, we boil water. We just boil water, and we have a string of metal. We put a string of metal in the boiling water, right? And then when it boils together, very quick, we take that metal, that hot metal, transfer it to the cold water, right? What's that you did?
Transfer electron?
No. Transfer the heat. So what kind of process is happening really there? Metal lost heat. Metal lost heat, exothermic. For metal lost heat, metal was warmer. When you put it in a cold water, metal lost heat, simply, right? Water, on the other hand, gains heat. endothermic. Now, you know, there is a calculation that you can calculate how much heat is lost by the metal, how much heat is gained by the water. You can calculate. That's not, you see, when I see your paper, many of you write Celsius. That's not right. That is temperature. That is the temperature difference. These are two different animals. These are two different things. The heat energy is measured in what? In joules, J, or calorie. Heat measured in calories. Heat lost or heat gained measured in calories or in joules. But the temperature difference is measured Celsius, Fahrenheit, Kelvin, whatever it is. Okay? For example, here, this is a good example.
So, wait, I have a question.
Yes.
So you said when we referring to heat lost or heat gain is in joules?
Yes. Heat lost or heat gain, it has to be either in joules or it has to be in calories. Okay? It has to be in joules or it has to be in calories. Yes. Okay. All this are the same thing here. Okay. Now I would like to discuss about reaction rate. Reaction rate. Sometimes some reactions are getting very slow, right? Sometimes some reactions are getting very faster. So in this case, we're going to see how reaction rate will be affected by the concentration and temperature. Let's start with a simple example. You have sugar with water. On one beaker, you have cold water, 100 milliliters of cold water with 5 grams of sugar. On the other one, you have hot water with 5 grams of sugar. Which one dissolves faster? Hot water dissolves faster. What is the factor for that? Yes. Increasing the kinetic energy of the molecule. When you have temperature more, the molecules will be increased. The molecules of water will be increased. They will be dispersed. Okay? They would have a lot of space. They would have a lot of rooms to interact with sugar because the molecules are not holding together, because if you heat something, they are expanded. So the molecules catch all the sugar, the solid sugar, so that the reaction will be faster. Okay? Also, you add the concentration of the reactants. Smaller concentration and higher concentration. If you have a smaller concentration, the reaction will be smaller. The number of collisions will be smaller. You see, for reaction, there must have collision. To increase the intensity, to increase the degree of collision, you must have more reactants. So that the more reactant, more collisions you created. That way, we increase the reaction rate, temperature, and concentrations of the reactants. We have a catalyst. A catalyst is a substance that speeds up the rate of reaction. You heard about catalyst in most cases. What does catalyst do? Actually, catalyst really doesn't have any effect in our body system, or catalyst doesn't have any effect in the chemical process. You pick the right catalyst. Enzymes, for example, are the right catalyst to regulate the bodies, our body system. In chemical reaction, the catalyst accelerates the reaction by lowering what we call the activation energy. You see, the activation energy means, for example, here, the energy that the reactants to change into products. There should be a certain energy. Okay? You can see a red curve and a blue curve. Okay? The blue one shows you the uncatalyzed reaction. Okay, the uncatalyzed reaction, that means it's a reaction without catalyst. There is a higher activation energy is needed. The lower one, which is the red curve, is the catalyzed reaction. There is low energy activation is needed. Activation energy basically means that the energy that is needed to convert reactants into products. How much energy is needed. What catalyst does is catalyst is like a GPS. Catalyst actually a nice GPS. All GPS are not nice. Some GPS, very smart GPS, they find a way, a shortcut. So, a shortcut way. So, you don't have to go all the way down up to here. They will find a shortcut for you. Catalyst doesn't affect the reactant, doesn't affect the concentration, doesn't affect the reaction process. Adding the catalyst really find a way for you to have quicker way to get into product. Okay, that's how they, so in other words, it lowers you down. Instead of going like from here to here to get into product. What's better? From here to here to get into product. Shortcut, here. It saves time. Catalyst does that. Okay? It's also focused on the environment catalytic converters. This is also that we have seen the catalytic converters. We have in our car, we have a converter. When you burn the gases, when you fill the gases, actually, we always get carbon dioxide and nitrogen. The amount of carbon dioxide, when you go to inspection, they measure the amount of nitrogen monoxide, the NO and the CO2, right? And then why you fail inspection? I failed a lot of times. All of us, right? If you have a bad car, we fail inspection. That is due to the converter. Okay? The converter, that is this one here. Yes, the catalytic converter, that you have to change your catalytic converter. Because it purifies the amount of carbon dioxide and the amount of nitrogen monoxide that releases from the car. You see, you have given a lot of carbon dioxide, nitrogen monoxide, which is not friendly to the environment if you don't have a good converter. But a good converter minimizes that, it breaks it down. It breaks it down. So sometimes we're not passing that test, inspection test, because we may not have a good converter, a good catalytic converter.
Is that the emissions test?
Yes.
The emission test, yes. I'm talking about the emission test, yes. Inspection, what did I say? Inspection? Emission inspection, right? Emission test, emission inspection, yeah. We've done chapter 5 here. We've done it. So, next week,